So dear learners, let us do the analysis of portal frame. The frame is actually a sway frame. It is subjected to a sway because of the unsymmetrical loading. So we have to do the analysis by slope deflection technique, and based on the results we can find the bending moment diagram. So we can see the portal frame, column AB and CD. The moment of inertia is going to be I. The height of the column is 4 meter, 4 meter, and the frame carries one beam which is subjected to point load 80 kilonewton at a distance of 5 meter from the left end. So this beam has to be, this total frame has to be analyzed by slope deflection method. So the total the symmetrical frame is unsymmetrical because of the loading condition. Even though the geometry is similar, it is unsymmetrical due to the loading condition, and there may be a sway. So let us assume the sway is to be right, and because of the fixity at D and A, support A and D, we can take theta A 0 and theta D 0, but theta B cannot be 0, theta C cannot be 0. Only the theta A and theta D is going to be 0. And fixed in moments, it's very easy because only the beam is subjected to loading, external loading. So for this loading condition, the FBC, fixed moment, minus WAB square by L square. So let us substitute AB as 5 meter, 3 meter. The loading intensity is 80. We can simplify. That is going to be minus 56.25 kilonewton meter. FCB is plus 93.75 kilonewton meter. So we can start writing the slope deflection equation one by one. Since there are three members, we can get six equations. First of all, MAB, fixed moment followed by moment due to the joint displacement. So theta A becomes 0, and del, where it is a column member, so it is subjected to uh, a sway of minus 3 del by L, which is a moment developed due to the sway. So simplify this, you can get the remaining term, that is equation 1. Similarly, MBC column will be subjected to del, and beam doesn't experience any del value. So as usual, MBC equation is written and it is simplified, minus 56.25 plus half AI theta B and 1 by 4 EA theta C. Similarly, we can write MCB, and this equation is 93.75 plus half EA theta C 1 by 4 EA theta B. MCD is 0, 2 EA by L, and remaining equation 2 theta C plus theta D is 0 and minus 3 del by L. So simplify this, you can get equation 5. And equation 6, half EA theta C 3 by 8 EA delta. So after getting the 6 equations, we have to write some boundary conditions to solve three unknowns, theta B, theta C, del. So let us take MBA plus MBC. Summation of moments meeting at the joint is equal to 0. So at joint B, we are supplying this condition and framing the equation. Similarly, at joint C, MCB plus MCD equal to 0. We have got one more unknown parameter, so we need the third condition. For that, I am writing the shear equations. Shear equation is horizontal shear HA plus HD plus it is resisted by the external force, that is equal to 0. So from based on this, HA means MAB MBA by 4, and HD is MCD MDC by 4 equal to 0. So from this we can get MAB plus MBA MCD plus MDC equal to 0. So now we have got equation number 7 based on the first joint condition, equation number 8 based on the second joint condition, and equation number 9 based on the third shear equation. So based on this three equations and three unknowns, we can solve it and find the unknowns theta B, theta C, and theta EA del. So that's going to be EI theta B 41.25 and EA theta C minus 78.75 and EI del minus 37.5. So using this unknown EI theta B theta C IA del, we can get the final moments also. MAB, we substitute the unknowns, we can simplify and get 34.69. MBA 55.31. MBC minus 55.31. MCD plus 64 and CD minus 64, MDC minus 25. So I am mentioning all the end moments obtained by this analysis. Then it is used to solve the frame simply by static equation of static equilibrium conditions. We can get the reaction HA, RC, RB, HD and everything. And using this we are plotting the BMD. So this is a final BMD in span. In fractal members, the span moment is superimposed with the end moments. So this is a way of solving the portal frame, which is subjected to uh, sway. That's because of the unsymmetrical loading. So here additionally one shear equation is involved. So if you are applying that shear equation, you can get the third unknown del, and you substitute as usual. You substitute all these parameters in the final moment equation. You can get the final moments, and with that we can do the we can get the final reaction shear force diagram, Bedingfield diagram, for which is useful for the design. Thank you.